Hello class, this is Martin Tellez and I am going to present to you my report on the sun for GLG 105 class. And this picture here, the first picture I chose, was odd because we usually think of the sun as yellow, and in this picture, the sun kind of looks like it could be a planet. And we're used to seeing it yellow all the times because the sun is a yellow dwarf star. And yeah, I thought this photo was pretty cool. Next slide here, we'll discuss the sun's size. And as you can see from this picture and relative to the other planets, the sun is huge. Also in this other picture here is our sun compared to other stars. So here's our sun here, this little dot. And this big, huge red is Betelgeuse, another star, which is huge. So you can tell the relative size from the sun to other stars in that picture. The radius of the sun is 690 million meters, 109 times the size of the Earth. So to put that into perspective, if the sun were a balloon blown up to about 1 foot across, the Earth would be the size of a peppercorn. I thought that was interesting. Our next slide here is the sun's location. And the sun here, this is our Milky Way. And here is our sun. It's right here by the Orion Spur and the Perseus arm. Here's the outer arm. You can see it's like spiral here, our Milky Way galaxy. The sun does not stay in one place, it does move. I know at one point in time it was believed that it did not move, but the sun does move. It doesn't stay in just one place all the time. Our next slide here is going to discuss the sun's structure. So I thought this picture was cool. It showed the inner parts of it. So we'll discuss the core. And the core of the sun, that's the region that extends from the center to about 20 to 25% of the whole solar radius. And it's here in the core where the energy is produced by hydrogen atoms that converts into nuclei of helium, which we'll discuss a little bit more, but that's what gives us energy. Next, we'll discuss the radiative zone, and this is the zone immediately next to the core, and there's no thermal convection in this layer, but solar material in this layer is hot and dense enough that thermal radiation is all that is needed to transfer the intense heat generated in the core outward. Next is the convective zone. This is the sun's outer layer, which accounts for everything beyond 70% of the inner solar radius. Here the temperature is lower and heavier atoms are not fully ionized. Next is the photosphere, and this is the visible surface. It's here that sunlight and heat are radiated and convected to the surface, propagate out into space. Next brings us to our energy and how the sun does energy, creates energy. So one of the reasons for this is because the Earth lies within our sun's habitable zone. So that's a reason why there's life here on Earth from the Earth's energy. So the simple answer for the sun and how it creates energy is like all stars, it's a massive fusion reaction. So scientists believe that this began when a huge cloud of gas and particles collapsed under the force of its own gravity, which is the nebula theory. So it's also triggered by a process where hydrogen is collected in the center and it begins fusing and it creates solar energy. So that radiates out into space, and it can come by ways of solar waves, CMEs, all different types of way that gets out into the solar system and can affect um, how things are out in the solar system. And here, 51% of the sun's energy is absorbed by the Earth. Here are my references, and I'd like to thank you for watching.